In this video, I will discuss the JEE Advanced PYQ from the topic Projectile Motion. First, let me give some basics. Projectile is a mass thrown from the surface of Earth at an angle theta with some initial velocity u. The only force acting on this projectile is the gravity force due to Earth, so that will be vertically downwards. So the path of the projectile will look something like this. It will go up, reach a maximum height point, and it will come down. So distance of the point where it hits the ground from the initial point. So this horizontal distance covered is called the range of the projectile, capital R. And the time it takes to go from here to here is the flight time, capital T, and it reaches the maximum height in the middle, and this height can be represented as capital H. So given the initial conditions, the velocity of the projection u and the angle theta, we can find the range, time of flight, and the maximum height attained in terms of u, theta, and g. So since there is no force acting on the horizontal direction, which is the x direction, and the vertical direction is y, when force is zero, acceleration is zero, according to Newton's second law of motion. When force is zero, acceleration is zero. So in the x direction, F is zero, so A is zero. So x direction motion is a uniform velocity motion. So the distance traveled in the x direction from here to here, which is the uniform horizontal velocity, that's u cos theta, in the time to go from here to here, which is the flight time t. To get the flight time, we can use these 2 points of the vertical motion and use this v equal to u plus at. So vy equal to uy plus acceleration is g downwards, upward direction is positive by convention, and the time it takes to go from here to here is half the flight time. By symmetry, the time to go from here to here is t by 2, and the remaining t by 2 it takes to go from here to here. At this point, the velocity is zero, vertical component, because velocity keeps on decreasing, becomes zero, and then turns back. And uy is the y component velocity here, which is u sine theta. U cos theta, horizontal component, vertical component is u sine theta. So from this, you get the flight time t as u sine theta by g into 2. So all these are known quantities. So if we use this thing here, we get the range. To get the maximum height, again use the vertical motion. V square equal to u square plus 2as. V square in the y direction, u square plus 2, e is minus g, and s is between these 2 points, it's capital H. From here to here, the displacement is plus h, because upward direction is positive, and Vy at this point is 0. So from this I get h as uy square, that's u sine theta whole square by 2g. There's another way of, okay, since t is known, I can put it here and get the range as u cos theta into this one. So this way I can find the range. There's one more way I can find the range. This range I can split as 2 parts. First half, the range is r, the distance traveled is r1. The second half, it's r2. So from here to here, the first half, I'll call this r1. And the second half, from here to here, it's R2. And let the time taken to go from here to here be T1, and the time it takes to go from here to here T2, second half time. So to find T1, I'll use these 2 points and use V equal to U plus AT. A is minus G. In the time to go from here to here is T1. So from this I'll get T1 as U sin theta by G. To find T2, I'll use S equal to ut plus half AT square between these 2 points. This is my initial point, this is my final point was second half. So S U is 0, ut plus half acceleration is G, because for the second half of the motion I'll take the downward direction as positive for convenience, and the origin is the maximum height point. So with this convention, acceleration is plus G because downward direction is positive, and half G T square. U is velocity at this point. This is my initial point for the second half. And S is plus H because of downward direction is positive. So H equal to U is 0. So this is half G T2 square. And H is same as this one because the first half I'll use this same relation. So H is known. So from this I'll get T2. U, theta and G are known. So T1 is known. And H is known from this one. So T2 is also known. So once I know T1 and T2, I can find the range as U cos theta into T1 plus T2. So with this understanding, we'll solve this JEE advanced question. This is the question. A projectile is fired from the horizontal ground with speed v and projection angle theta. When the acceleration due to gravity is g, the range of the projectile is d. If at the time of highest point in its trajectory, the projectile enters a different region where the effective acceleration due to gravity is g prime, which is g by 0.81, then the new range is d prime, which is n times d. The value of n is dash. You can pause and run this question. So in the first case, the projectile is at an angle theta. So it goes like this and hits the ground somewhere here. Okay, this range is range in the first case, which they represented as d. Okay, here in the first case, the gravity is same throughout, g. So this range is standard calculation. If you remember the formula, you can straight away use it, or you can do this thing quickly. Range is u cos theta into the flight time, and time of flight you can get the vertical motion Vy equal to Uy plus acceleration is minus g in the time it takes to go from the maximum height point is t by 2. This will give the flight time as Vy is 0 at this point, maximum height point, is u sin theta 2 by g. So if you use this thing here, range in the first case is 2 sin theta cos theta sin 2 theta u square by g sin 2 theta. Sin 2 theta is 2 times sin theta cos theta. Or if you remember this formula, you can straight away use this one. In the second case, the projectile is thrown from the ground with velocity v and angle theta. So until it reaches the maximum height point, the gravity is g. At the maximum height point, it enters a different region where the gravity force has changed to g prime, and g prime is actually more than g because g by a fraction, which is more than g. So the gravity field is stronger, so it will come down faster. Something like this. So this distance covered, R1 we can find out, and this distance covered in the second half is R2. So the range of this second projectile of the second case projectile is R1 plus R2. So R1 we can get as u cos theta into the time to go from here to here, that's T1. And T1 you can get from the vertical motion. This point and this point. So using Vy equal to Uy plus A is minus G, because upwards is positive for this first of the motion. This is my coordinate system, positive direction for the y-axis. So G is acceleration is minus G, and the time to go from here is T1. T1. So this will give me T1 as V at this point is 0. So U sin theta by G. And to get R2, first we'll get the maximum height h from the first half. So to get that, we have to use V square equal to U square plus 2AS. A is minus G because upward direction is positive, and S is between these 2 points is H. So that will give H as Vy at this point is 0. So H is U sin theta square by 2G. Okay, so this H is so between these 2 points, the displacement is H. So if we use is equal to ut plus half at square, between these 2 points, and for this second half of the motion, my coordinate system will be like this, the y direction. I'll take downward direction as positive, and this is the origin, the maximum height point. So between these 2 points, the displacement is plus H because downward direction is positive. And initial velocity is 0. It's a turning point, so velocity is the minimum here, and it's 0. So first term is 0, and acceleration is plus G because downward direction is positive. Or actually here it's G prime, the different gravitational field. And the time is T2 square. Time to go from here to here is T2. The flight time is being split into 2 parts. T1 to from here to here, and T2 is from here to here. So from this, 2h by G prime, that is T2. Okay, and H I have to use this one. T2 square. Okay, so 2 times H by, so H is, okay, G prime is G by 0.81. That's given in the question. G prime is G by 0.81. So this is 2h by by G by 0.81 will go up. That's equal to T2 square. And 2h by G is 2h is 2h by G is U sine theta square by G square. As you can see from here, I can take this 2 here. So 2h is U sine theta square by G, and one more G itself will become G square into 0.81. That's T2 square. So from this, I'll get T2 as take square root of both the sides. It's U sine theta by G into square root of 0.81. Okay. So, and T1 is U sine theta by G into 1. So the total time from here to here is T1 plus T2. In the second case, the flight time is U sine theta by G into 1 plus square root of 0.81 is 0.9. 0.9 into 0.9 is 0.81. So in the first case, the flight time is U sine theta by twice. There it is reduced by 1.9 because the gravity is stronger here. So it'll pull it down faster, so it'll reach the ground faster. Okay. So range in the second case, then we call it R mu, which is R1 plus R2, which is same as U cos theta into T1 plus T2. Which is U square by G. Sin theta cos theta is sin 2 theta by 2 into T1 plus T2 is 1.9. So this range is 1.9 by 2, that's 0.95. So this is equal to 0.95 into the original range. So the new range is reduced from the old range by a factor 0.95. So R is reduced by a factor of 0.95 compared to the old range. So the answer to the question is n equal to 0.95 because they are asking the factor by which the range has reduced. The new range is n times the old range. So this factor is 0.95. 0.95 is the correct answer. So this is what I explained here. In the first case, the range is U cos theta, the x direction velocity, and x direction the motion is uniform velocity motion because there is no force in the x direction. The only force is due to gravity, that's in the y direction. So the range is U cos theta in the flight time. To get the flight time, this is the standard way. The vertical motion, v equal to u plus at, and time to go from the ground to the maximum height point is t by 2. And acceleration is minus because downward direction, upward direction is taken as positive. So flight time is this one. So if you remove this formula, you can straight away use it. And h I can reconstruct like this is equal to vt minus half at square between the ground point and the maximum height point. So displacement is h, and v at the maximum height point is 0, and acceleration is minus g, and time is t by 2. Time to go from ground to the maximum height point. So from this, get the height as half u sin theta square by g. Range, I have to use this flight time in this here. So you'll get u square by g sin theta. This is the standard formula. If you remember this, you know how to derive these things. So this is the range in the first case. In the second case, the projectile is entering a region of stronger gravity in the second half. So it's actually non-symmetric. It won't be a parabola. Parabola is symmetric about the midpoint. So range in the second case is u cos theta, which is same for the first half and second half because there is no force in the vertical horizontal direction. So it's u cos theta throughout. And the total time is t1 plus t2. T1 is the first half flight time. T2 is the second half. So to get the first half flight time, u is equal to u plus at. And for the first half, the upward direction is positive, the y direction. And the origin is the ground. So with this convention, acceleration is minus g. From this you get t1, the flight time. For the first half is u sin theta by g. Second half, I'll use the downward direction as positive. It's convenient to use this one. And the origin is the maximum height point. So this is completely different from here, first case. So S is plus h because downward direction is positive. And u is 0, the velocity of the maximum height point. And acceleration is g prime, the new stronger gravity. And it's downward direction, and downward direction is positive. T2 square. So from this I get T2 as, and g prime is g divided by 0.81. That's given in the question. So from this get T2 as u sin theta by g square root of 0.81. This is given in the question. So the range in the second case, horizontal velocity so it is same as the first case. There is no force change in the horizontal direction. There is no force in the horizontal direction. With the total flight time, that's u sin theta into t1 plus t2. So you'll get u sine by sin 2 theta because sin 2 theta is sin theta into cos theta into 2. So the 2 is not there. So put the 2 and divide by 2. So the divided by 2 is here. So this, this is the range of the first case. So this is r, and this is by 2, and the square root of 0.8 is 0.9. So 1.9 by 2. 1.9 by 2 is 0.95. So the new range has decreased by a factor of 0.95. Since the gravity is stronger in the second half, it comes down faster. The time for flight has reduced because the range is reduced, and the factor of the detection of the range is 0.95.